convert scientific and standard notation. So say we have an example that's like 9.85 times 10 to the fourth. Now, what does this really mean? Well, the A, which is this, right? Well, A is going to be 1 through 10, and it has a decimal after the first digit. So notice that we have a decimal after the 9. So that would be the proper way to do scientific notation for A. Now, B, right, this is our B. B is going to be a number of times the decimal moves. Now, if we have a positive B, like we do here, it means we're going to have a really big number. Or at least larger than 1. Now, if it's a negative B, that means we're going to have a small standard number. So, for a big standard number, if we were to use, say, this example, it means that we're going to have to move the decimal 4 times because we have this 4, which is the B. How many times we have to move it over? So if we have this, it means we move the decimal over 1, 2, 3, 4, right? So these are equivalent if we were to represent them in standard notation or scientific notation. Now, what if we had a small standard number? So say we had how do we represent this in scientific notation? So if we were to convert this, we move the decimal over 1, 2, 3, 4, 5. Because we want it between the 9 and the 8, because everything else before that is just a 0. So we would represent as 9.85 times 10 to the, remember it's negative because it's a really small number, it's less than 1. And that's how we represent it as scientific. So now let's look at some example 1, convert to standard notation. So we notice we have 5.23 times 10 to the 5th. So we have a positive B, right? This exponent is positive. So that means we're going to move the decimal over to the right in order to get a bigger number. So what I like to do is kind of add a couple zeros to this number, and then I'm going to move the decimal over 1, 2, 3, 4, 5. So we get this very large number. So, right, that's our decimal right there. So we have 523,000 for this. So that would be our solution. Notice you do not have to add the decimal there. I just added it just to make a point that this was a comma, that was our decimal. Now let's do another example. Example 2. E. coli bacteria is about 2.5 times 10 to the negative 5th meters long. Let's convert this to standard notation. So, if we have a negative exponent, that means we need to move the decimal to the left to make it a smaller number, right? So we're going to make a smaller number that way. So let's go ahead and add zeros. And then we're going to move the decimal, right? This has a 5. So we need to move it over to the left 5 times. So we go 1, 2, 3, 4, 5. So we end right there. So we have 4 zeros and then the 2, 5. So that's how long E. coli bacteria is in meters in standard notation. Let's do another example. Example 3. Earth's orbital speed around the sun is 67,000 miles per hour. Let's convert 67,000 to scientific notation. So what we need to do is convert this to scientific notation. Now, we have a period here, but we really want it to be between the 6 and the 7. Because what we want to do is have a digit, that's a number between 1 through 9, so any of those digits. And then we have a decimal and then any other numbers after. So let's go ahead and move this decimal. So we're going to move it 1, 2, 3, 4. So we're going to end it right there. So this becomes 6.7. These are zeros that we do not need to count because it's the same kind of if we were to add them or not add them. So let's just not add them. And we moved over 4 times. Now this is a large number, so that means we need to have a positive exponent. So that'd be 4. And that would be for miles per hour. So that would be our solution. Now let's do another example. Example 4. The spherical coronavirus virons have a diameter about the size of 0.000000125 meters. So let's convert this to scientific notation. Well, to get this to scientific notation, we need to move it to the right. So that means we're going to have a negative exponent, and we need to know how many. Well, we need this new decimal to be between the 1 and the 2, because the 1 is the first digit that's not a 0, so it actually counts. So we have this 1.25 is what we want it to be. So let's go ahead. 3, 4, 5, 6. So there's 6 zeros, and then the 1, 2, 5. In order to move this, we need to move it 1, 2, 3, 4, 5, 6, 7. So we ended right there. So that becomes 1.25 times 10 to the negative 7, because we need that negative, right, exponent. And we moved it over 7 times. And this is for meters.